Hi everyone, welcome to MathSux. This video is going to help you pass the Common Core Regents. So we're doing this one question at a time. Here's part 2 with question 25. In triangle ABC below, use a compass and straight edge to construct the altitude from C to AB. So we're focusing on this angle here, C, and we'll get our compass and straight edge out. So let's put our point onto C and then open up our compass a little bit. And just swing it around, making sure that the arc intersects at 2 points on AB. So we have this point and this point. So now I'm going to take the point and bring it to one of these points on AB. And I'm going to swing and make an arc up top and down below. And then I'm going to keep that same distance and bring the point to the other point along AB that we made, and then do the same thing, an arc down. So notice we have these two cross sections we made here and here, and that's where we're going to connect the points. So from C to D is going to go through these 2 points, and this will be our altitude. Question 26. Triangles ABC and DEF are graphed on the set of axes below. Describe a sequence of transformations that maps triangle ABC onto DEF. So we're going from ABC to DEF, so we're going this way, which you can see kind of looks like a rotation of 90 degrees, which is exactly what this is going to be. So we're going to say rotation. And if we wanted to check to make sure we're right and there's no more transformations to do, take an example of 2 points that would be mapping onto each other. So if you notice, if we did rotate this 90 degrees, A would become D. So point A is 0, 4. And if we rotate in 90 degrees, the rule for that is that we're going to switch and negate the X. So we're going to switch this and negate this, but this is a 0, so that's going to stay the same. So I'm just going to write the rule on the side here for clockwise. Just want to make sure that's in our answer. So what we have is we have a point xy, and it becomes y comma negative x. So if you look at point D, 1, 2, 3, 4, you'll see that it's 4, 0. So that works out. So if you can check all the points if you want. So if we checked B, would become E. So B, let's see, is 1, 2, 8. And then if we rotated it, it would become 8 comma negative 2. So if you look at E, we have 1, 2, 3, 4, 5, 6, 7, 8, and then negative 2. So this becomes E. So this looks right. So our answer here is rotation of 90 degrees about the origin clockwise. Question 27. Line segment PQ has endpoints negative 5, 1 and 5, 6, and point R is on PQ. Determine and state the coordinates of R such that PR to RQ is 2 to 3. So let's look at all the information we're given here. We have this coordinate, negative 5, 1, 5, 6, and then this ratio, 2 to 3. So I'm just going to label these x1, y1, x2, y2, and ab. And what we're going to do to solve this is there's a formula for an x coordinate and a y coordinate. And we'll be using all this information to plug it in. So we have x equals negative 1. We have 1 part of our coordinate, and now we're going to do the same thing for y. So now when we put all our numbers together, we'll have negative 1 for x and 3 for y. So we get an answer of negative 1 comma 3. Question 28. A circle has a radius of 6.4 inches. Determine and state the nearest square inch the area of a sector whose arc measure is 80 degrees. So first let's draw a circle, and it has a radius of 6.4, and it's saying there's a sector that measures 80 degrees. We have to find the area of it. So the area of a sector is a lot like the area of the circle, pi r squared, but now we have this x degrees divided by 360 degrees, kind of like you're taking the area of the square and then dividing out the piece of the pi that you want. So in this case, we're going to have pi times 6.4 squared, and then the degrees we're working with is 80 degrees over 360. And then you could just plug this into your calculator. And they want it to the nearest square inch, so this will be 29. Question 29. A large snowman is made of 3 spherical snowballs with radii of 1 foot, 2 feet, and 3 feet, respectively. Determine and state the amount of snow in cubic feet that is used to make the snowman. So we're going to be finding the volume of all 3 circles, all 3 spheres. So we have this snowman. So let's pretend these are perfect circles where the radius is 1, the radius is 2, and the radius is 3. So we want to find the volume of each of these and then add them all up. So the volume of a sphere is 4/3 pi r cubed. So if we have each of these, we're just going to do 4/3 pi where the radius is 1 cubed plus 4/3 pi where the radius is 2 cubed plus 4/3 pi where the radius is 3 cubed. And then we could just plug this in. Oh, we can leave our answer in terms of pi, which is nice. So this will just become 4/3 pi. So now you can just add these all together. We get 144 over 3 pi, which we can reduce to 48 pi. Question number 30. In the diagram below of right triangle ACB, altitude CD is drawn. So we have this other right triangle to hypotenuse AB. AD equals 2 and AC equals 6. Determine and state the length of AB. So when we look at this, we want to find the length of AB, right? So we want to find the length of this whole thing, AB. So to do that, we're going to use this little triangle, this little right triangle here. And then this big giant triangle that we started with. So notice both are right triangles. So because both are right triangles and both share an angle A, we know that these triangles are similar to each other and that we can make a proportion. But to do that, we just want to make sure that our triangles are in the right order. So notice that this big triangle, we have the right angle up here. So we want to flip this around, kind of like flip and rotate it. So it looks like this, it matches the shape of this triangle. So D is up here. The short side has a length of 2, and the long hypotenuse has the length of 6. So now we can make a proportion. Notice we have the short side 6 over 2, and we can set it equal to the unknown AB over 6. And then we could just cross multiply and solve. And we get AB is equal to 18. And I have a couple of questions just like these if you want to practice. So be sure to check those out. Question 31. Triangle RST has vertices with the coordinates -3, -2, 3, 2, and 4, -4. Determine and state an equation of the line parallel to RT that passes through point S. So first, let's draw out this triangle. So let's look at this question again. We want an equation of the line parallel to RT. So if we look at RT, over here we want a line that's parallel to this. So let's find the slope between these 2 points. So R is -3, -2, and T is 4, -4. So to find the slope, we're just going to do the change in Y over the change in X. So here, this leads us to get a -4 minus -2, or -4 plus 2, and 4 plus 3. So we get -2/7. So since we want them parallel, we know we're going to keep the same slope. So another thing it said is that this equation of the line is going to pass through point S. So point S right here has the value of 3, 2. Using an equation of line in point slope form, we can fill this out right away. So we have our point is going to be 3, 2, and our slope is going to be -2/7. So our point slope form is just the formula y minus y1 equals m times x minus x1. So if we fill this in, we're going to get y, this is x, this is y, minus 2 equals the slope -2/7 times x minus 3. Question 32. Cape Canaveral, Florida is where NASA launches rockets into space. As modeled in the diagram below, a person views the launch of a rocket from observation area A, 3,280 feet away from launch pad B. After launch, the rocket was assigned at C with an angle of elevation of 15 degrees. The rocket was later sighted at D with an angle of elevation of 31 degrees. Determine in states of the nearest foot the distance the rocket traveled between the two sightings C and D. So our main thing is we want to find what's here between C and D. But notice we have this right angle. Knowing that, we can use SOHCAHTOA to find out how big this value is from C to B and how big this value is from B to D, and then subtract them and we'll be left with X. So if we look at this big triangle first, so I'm just going to redraw it. We have A, and then this whole thing is 31 degrees, D, and then B. And then this is a right angle. And then down here we have 3,280 feet. So we have, look at the information we have, we want to find this, the value of dB. So we will have our angle, and we want to find the opposite, and we have our adjacent. So we have adjacent and opposite, so we're going to deal with tan. Tan of 31 degrees is equal to the opposite, which we don't know, over 3,280. So we just need to cross multiply. We'll get 3,280 times tan of 31 and see what that is equal to. So we get 1970. So this whole thing right here, dB, is equal to 1970.82283. And I'm not going to round yet until the end. Okay, so we did part 1. Now let's find CB. So to find CB, I'm going to look at this smaller triangle where we have 15 degrees, the unknown CB, a right angle, and then 3,280. So notice, again, we're going to want to find the value of this missing value, CB, the opposite. We have the adjacent, so we're going to be using tan again, the opposite and adjacent. So we have tan of 15 degrees is equal to x, the opposite, that's unknown, over the adjacent, 3,280. So now we can plug this in, and we'll get 878.8733512. So that's what is equal to over here, just CB. So now we have the value of the whole thing, the value of just CB, so we can find this value of C d, which is what they're looking for. So to do that, we're just going to subtract. So we have 1970.82283 minus the number we just found, 878.87. And let's see what that is equal to. We get 1091.949. And if you look back, they want it to the nearest foot, so we can say this is equal to 1092. Question 33. A small can of soup is a right circular cylinder with a base diameter of 7 centimeters. So let's just draw out what that looks like. We have a little cylinder with a base diameter of 7 centimeters and a height of 9 centimeters. A larger container is also a right circular cylinder, so let's draw a bigger cylinder. And this has a diameter of 9 centimeters with a height of 13 centimeters. Determine and state the volume of the small can and the volume of the large container to the nearest cubic centimeter. So we're going to be finding the volume of the small container and the volume of the big container. So let's find the volume of the small. So they're going to have the same formula because they're both cylinders. So this is just pi r squared h. So we have pi. R is going to be half of the diameter, which is 3.5 squared, times h, which is 9. We end up getting 346. And now the volume of the big cylinder. We have the same formula, except now our radius is 4.5 times the height, which is 13. And here we get 827. So that's the answers for the first part of this question, and then there's a second part. What is the minimum number of small cans that must be opened to fill the larger container? So since we have volume of the big container and the small container, we can just divide the big container divided by the small container. So notice we get 2.39. So we get this decimal. So since we have 2 and a little bit more, we know we're going to need at least 3 cans. Question 34. Parallelogram math has vertices -7, -2, 0, 4, 9, 2, and 2, -4. Prove that parallelogram math is a rhombus. So the first thing I'm going to want to do is to graph this on the coordinate plane below. So let's do that first. Okay, so we have our rhombus, and now what we're going to do to prove that this parallelogram is a rhombus is we're going to measure each side of points and see the distance between them, and we'll see that these are all going to be equal to each other, and that will prove that this is a rhombus. So we'll start by looking at points M and A. So we have our coordinates of M and A, and we're just going to use the distance formula. Which is x2 minus x1 squared plus y2 minus y1 squared, and all over a square root. So let's just plug in these coordinates into our formula. And we get radical 85. So over here we have radical 85. Okay, so that's one pair of points. Now let's try the next, A and T. I'm just doing the same distance formula. and we get radical 85 again. Okay, our next pair of points is T and H. Okay, so we get radical 85 again. And then our last pair of points, we have M and H. And we get radical 85 again. So we know that all these sides are equal and that this quadrilateral is a parallelogram. So, okay, so on to the next part. Determine and state the area of math. So we want to find this area here of our rhombus. So what I'm going to do to start off is actually draw a rectangle going all around our rhombus. So first let's find our area of this, our big rectangle here that we have, which will be 16 by 8, which gives us 128. So that's the area of the rectangle, but we want the area of the rhombus. So notice that we formed 4 triangles going all around. And that if we add up the areas of these triangles and then subtract them, we'll be left with our rhombus inside. So that's exactly what we're going to do. We're going to find the area of triangle 1, which is just going to be 1/2 base times height. So the base is 1, 2, 3, 4, 5, 6 times the height, 1, 2, 3, 4, 5, 6, 7. And this will just give us 21. The area of triangle 2 over here is going to be 1/2 times 2 times the height, which is just going to be 9. Area of triangle 3 down here, we're going to get the same thing. And then our 4th triangle, it's going to end up being the same as triangle 2, and we'll get 9. So now that we have all this information, we're going to take the rectangle, the area of the rectangle, 128, and then subtract out all these triangles. So subtract 21 plus 9 plus 21 plus 9. And we get 68. And that's our answer. Question 35. Given quadrilateral ABCD, AB is congruent to CD, AB is parallel to CD, and diagonal AC intersects EF at G, and DE is congruent to BF. Prove G is the midpoint of EF. So this one's a little tricky. We're going to be trying to prove that triangle AEG over here is congruent to triangle FGC over here. And then because of that, we'll say that EG is congruent to GF, and then because of that, we can say that G is the midpoint of EF. So there's a couple different steps. I'm just going to write down our goal on the side. So even though we have to prove G is the midpoint of EF, I'm just going to break down our goal. So we want to prove triangle AGE is congruent to triangle FGC, and then prove the sides EG congruent to GF, and then the midpoint. So a couple of steps, and there's going to be multiple steps besides this too. So how are we going to prove these two triangles congruent? So the first thing I see right away is vertical angles. The next thing I see is that we can prove that this ABCD, this quadrilateral, is a parallelogram, and we can prove that sides AE and FC are congruent to each other by the subtraction postulate. So I can mark that. So now we have an angle and a side. And another thing, if this is a parallelogram, when we prove that, AC is cutting these parallel lines at like a transversal. So we could say that alternate interior angles are congruent. So we could say that this angle is congruent to this angle by alternate interior angles. So here we have angle, angle, side. So we're going to prove this by angle, angle, side. So just to give you a little outline of what we're going to be doing, but we'll break this down even more step by step and write out the statements and reasonings we're going to need. So let's start doing that. So the first step that we're always going to start with our proof is just to write out everything they gave us. So everything that's given here. And the reasoning for all this stuff here is that it's given. So that's always our first easiest step. So next, we can start by saying quadrilateral ABCD is a parallelogram. And we know that because a quadrilateral with a pair of opposite sides that are parallel and congruent, which are A, B, and D, C, which they gave us, is a parallelogram. Okay, so now that we know this is a parallelogram, we can say that AD is congruent to BC. So this whole side is congruent to this whole side. And we know that because we just stated it's a parallelogram. And the opposite sides of a parallelogram are congruent. Next we can say AE is congruent to CF. And this is based on the subtraction postulate. So we're saying, so just to outline, so we're saying AE is equal to CF. So I'm just going to circle this so we know that this is in blue. So these two are congruent to each other. Okay, number 5. Our next piece of this is we can say AD is parallel to CB. And similar reasoning where opposite sides of a parallelogram are parallel. And because of this, we can say that angle EAG is congruent to angle FCG. So I'm just going to highlight this in purple. So angle EAG is congruent to angle FCG. And this is based on when a parallel lines are cut by a transversal, alternate interior angles are congruent. Next we can talk about the vertical angles happening at G. Saying they're congruent, so angle EGA is congruent to angle CGF. and this is just based on vertical angles. So now we have all the pieces we need. We have our angle, angle, side. So we can say that these two triangles are congruent to each other. By angle, angle, side. So because of that, we know that this line EG, which is part of the triangle, is going to be congruent to line GF. And that's because of CPCTC. Congruent parts of congruent triangles are congruent. So, because of that, we know that G is a midpoint, which is what we were trying to prove this whole time. G is the midpoint. And the reasoning for that is that since G divides EF into two equal parts, G is a midpoint. So this is the end of our test. I hope this was helpful. Good luck and happy calculating. So if you're looking for more on this test, check out the playlist in the link below. And thanks for stopping by. Happy calculating. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!